Isaac Newton, born in England in 1643, grew up fatherless and isolated, yet became the man who redefined the universe. At Cambridge, while England battled the plague, he worked in solitude and produced discoveries that would anchor modern science. By his mid-20s, he laid down the laws of motion and universal gravitation, mathematics proving that the same force pulling an apple to Earth also governs the planets in orbit. His 1687 masterpiece, Principia Mathematica, is often called the single most influential book in science, launching the clockwork universe era. Newton invented calculus to solve these problems, developed the first practical reflecting telescope, split white light to reveal the spectrum of colors, and even set the foundation for modern optics. He later became master of the Royal Mint, rigorously reforming England's currency and punishing counterfeiters. His genius didn't just explain the heavens, it powered the scientific revolution that fuels every rocket launch, engineering principle, and physics classroom today. Albert Einstein himself said, "Every scientist stands on Newton's shoulders." From a lonely child to the architect of the modern world, Newton's legacy is not just in dusty equations. It's in every step, every machine, and every orbiting satellite above us. Albert Einstein, born in Germany in 1879, looked like an ordinary student, slow to speak, rebellious in school. Yet he became the physicist who bent space and time. In 1905, while working as a patent clerk, he dropped 4 papers in what's now called the miracle year. These included his special theory of relativity, showing that time is not absolute, and E equals mc squared, the simple but terrifying equation proving mass and energy are interchangeable. A decade later, his general theory of relativity revealed that gravity isn't a pull but a warp of space-time itself, predictions later confirmed during a 1919 eclipse. Almost overnight, Einstein became a global icon. He won the 1921 Nobel Prize, not for relativity, but for explaining the photoelectric effect, a cornerstone of quantum physics, the science behind solar panels and modern electronics. Einstein warned against fascism, fled Nazi Germany, and helped alert the US about nuclear weapons, though he remained haunted by that legacy. Today, his theories underpin GPS, nuclear power, black hole physics, and the entire modern cosmos. He didn't just change equations, he changed how reality itself is understood. From a quiet clerk to the most recognizable genius on Earth, Einstein proved imagination is as powerful as intellect, and left us with a universe forever curved by his vision. Charles Darwin, born in 1809 in England, was an unremarkable student. He dropped out of medical school and nearly pursued life as a clergyman. But at 22, he joined the voyage of the HMS Beagle, a 5-year journey that would forever change human history. Observing fossil beds in South America, finches on the Galapagos Islands, and patterns across continents, Darwin saw one radical truth. Species aren't fixed, they evolve. After decades of study and hesitation, in 1859 he published On the Origin of Species, presenting the theory of evolution by natural selection. The idea was explosive. It challenged centuries of religious dogma, suggesting humans were not specially created but part of the same natural process as every living thing. Yet the evidence was overwhelming. Darwin's work unified biology under a single principle: life adapts, survives, and changes. His theory explained the diversity of species, extinction events, and the hidden logic of survival, the survival of the fittest. Today his influence runs through genetics, agriculture, medicine, and even psychology. Without Darwin, DNA science wouldn't make sense. Vaccines, evolutionary medicine, and conservation would have no foundation. From a seasick young naturalist to the father of modern biology, Darwin's legacy is staggering. He taught us that we are not separate from nature, but deeply embedded within it. Nikola Tesla, born in 1856 in modern-day Croatia, had a photographic memory and could design machines entirely in his mind. After emigrating to the United States in 1884 with just a few cents in his pocket, he joined the world of Thomas Edison, quickly becoming both collaborator and rival. Tesla's obsession was electricity. He championed alternating current, AC, safer and more efficient than Edison's direct current. The so-called War of Currents ended with Tesla and Westinghouse electrifying the 1893 Chicago World's Fair and proving AC could power entire cities. That victory still powers your home today. But Tesla's genius went far beyond AC. He pioneered the induction motor, the Tesla coil, wireless radio transmission, early radar concepts, and dreams of wireless global energy. At Colorado Springs, he created man-made lightning bolts more than 40 meters long. Yet he struggled financially, often betrayed or sidelined, and died penniless in New York in 1943. Despite this tragedy, his vision was prophetic. Wireless communication, radio waves, renewable power grids, all trace back to Tesla's imagination. Today, he's seen as the archetype of the mad genius, a man ahead of his time, whose ideas built the backbone of modern technology while inspiring generations of innovators. From forgotten inventor to cult icon, Tesla's real legacy is simple. He lit the modern world. Galileo Galilei, born in 1564 in Pisa, with a restless mind of the Renaissance. Originally trained for medicine, he turned to mathematics and physics and quickly built a reputation for challenging tradition with evidence. With a telescope he improved himself. Galileo looked into the night sky and shattered centuries of belief. He discovered the mountains of the moon, the phases of Venus, Jupiter's 4 largest moons, and countless stars invisible to the naked eye. These findings confirmed Copernicus's radical idea: the Earth moves around the sun. But saying so was dangerous. In 1633, after publishing dialogue concerning the 2 chief world systems, Galileo was summoned before the Inquisition. Condemned for heresy, he spent his final years under house arrest, famously muttering, "And yet it moves." Yet his contributions extended beyond astronomy. Galileo pioneered the scientific method, conducting controlled experiments on motion, acceleration, and inertia. He laid the groundwork for Newton's later laws of physics. Ultimately, Galileo represents more than data. He embodies the courage to put truth above authority. Today, every experiment in every lab owes something to the man once branded a heretic. From gazing at Jupiter's moons to redefining humanity's place in the cosmos, Galileo proved that the universe doesn't bend to human dogma, it bends to evidence. Marie Curie, born Maria Sklodowska in Poland in 1867, moved to Paris with almost no money, studying by day, tutoring at night, sometimes fainting from hunger. Yet she became the first woman to win a Nobel Prize, and the only person ever to win 2 in 2 different sciences. Working with her husband Pierre, she discovered polonium and radium, coining the term radioactivity. Her meticulous experiments isolated elements invisible to the eye, ushering in a new era of physics and chemistry. She developed mobile X-ray units during World War I, treating thousands of wounded soldiers. But Curie also paid a heavy price. Years of exposure to radiation damaged her health, and she died in 1934 from aplastic anemia. Her notebook so radioactive they're still unsafe to touch today. Her legacy is immense. Radiation therapy for cancer, nuclear medicine, atomic physics, all trace back to her groundbreaking work. She broke barriers for women in science, becoming the first female professor at the University of Paris. Marie Curie's life is more than discovery, it's devotion. Against poverty, sexism, and danger, she pushed forward, leaving behind not just Nobel medals but tools that save lives every day. From a struggling student to a scientific immortal, Curie lit the path for modern medicine and generations of women in science. James Clerk Maxwell, born in Scotland in 1831, was a quiet prodigy who published his first paper at just 14. Unlike Darwin or Einstein, you may not hear his name often, but physicists rank him alongside them as one of the greatest minds in history. Maxwell's crowning achievement was uniting electricity, magnetism, and light into a single framework. In 1865, he published Maxwell's equations, 4 elegant formulas showing that light itself is an electromagnetic wave. With that, he revealed that electricity, magnetism, and optics were not separate forces but one phenomenon. This discovery opened the door to the entire modern world. Radio, radar, television, cell phones, the internet, every wireless technology owes its existence to Maxwell. Einstein himself said his own theories would not have been possible without Maxwell paving the way. Beyond electromagnetism, Maxwell advanced color photography and developed the first true explanation of gases, laying the foundation for statistical mechanics. Maxwell died young, at 48, but his influence is everywhere. Every time we send a text, beam Wi-Fi, or look at a rainbow, we're standing inside his field of vision. Quiet, humble, and brilliant, James Clerk Maxwell gave humanity the invisible threads that connect the modern world. Stephen Hawking, born in Oxford in 1942, was diagnosed with ALS at just 21 and told he had only a few years to live. Instead, he went on to reshape cosmology and inspire millions for more than half a century. Hawking's great insight, with Roger Penrose, was that the universe itself had a beginning. The Big Bang was rooted in Einstein's equations. He later proved that black holes aren't black at all. They slowly evaporate by releasing radiation, now known as Hawking radiation. If true, it connects quantum mechanics and gravity, 2 pillars of physics still irreconciled. Despite near-total paralysis, he wrote A Brief History of Time in 1988, selling more than 25 million copies, making advanced cosmology accessible to everyday readers. His robotic voice and wheelchair became global symbols of resilience, showing the power of the mind when the body fails. Hawking's impact wasn't just equations, it was hope. He opened the cosmos to the public and reminded the world that intelligence, imagination, and courage can thrive against impossible odds. Stephen Hawking didn't just study black holes. He became a star of his own, a man who expanded humanity's sense of the universe and of human possibility. Louis Pasteur, born in France in 1822, was not a top student. His teachers once doubted his abilities. Yet he became the man who saved more lives than perhaps any other scientist in history. Pasteur proved what no one could before him. Tiny microbes cause disease. His germ theory overturned centuries of medical belief, revolutionizing how we fight illness. He showed heat could kill bacteria, creating pasteurization, still used today in milk, wine, and countless foods. He developed vaccines for rabies and anthrax, and his method of weakening microbes became the blueprint for all modern vaccines. During the Franco-Prussian War, he personally fought to deliver vaccines to soldiers, saving thousands from outbreaks. By linking unseen germs to visible death, Pasteur armed humanity with a new weapon. Hand-washing, sterilization, vaccination, all are his legacy. The average human lifespan skyrocketed thanks to him. Pasteur's impact isn't abstract. It's in every hospital, every sterile operating room, every sip of safe milk. More than 100 years later, every life saved from infection silently carries his mark. From doubted student to father of microbiology, Louis Pasteur didn't just study life, he protected it. Gregor Mendel, born in 1822 in what is now the Czech Republic, was a quiet Augustinian monk with a passion for gardening. In the monastery garden, he planted thousands of pea plants, carefully crossbreeding them and recording each trait: flower color, seed shape, plant height. Through meticulous study, he discovered something revolutionary. Traits are inherited in predictable patterns. He revealed the fundamental laws of heredity, dominant and recessive genes, long before anyone knew what DNA was. At the time, few took notice. Mendel's 1865 paper was overlooked by the scientific world, and he died in 1884 without recognition. But decades later, scientists rediscovered his work, realizing he had founded genetics itself. Today, every branch of biology, DNA sequencing, agriculture, evolution, medicine, rests on his principles. His laws explain how diseases are passed, how crops are engineered, how species adapt. J. Robert Oppenheimer, born in 1904 in New York, was a brilliant physicist fluent in multiple languages and fields, from quantum mechanics to Eastern philosophy. In 1942, at just 38, he was chosen to lead the Manhattan Project, the secret U.S. race to build the atomic bomb during World War II. Under his leadership in Los Alamos, thousands of scientists developed a weapon that split the atom. In July 1945, the first nuclear test, Trinity, turned night into day with a blast hotter than the sun. Oppenheimer recalled a line from Hindu scripture: "Now I am become death, the destroyer of worlds." 1 month later, atomic bombs fell on Hiroshima and Nagasaki, ending the war but killing over 100,000 civilians. Oppenheimer instantly became famous and haunted. He later opposed further nuclear escalation, warning against the hydrogen bomb, and was eventually stripped of his security clearance during the Cold War. Oppenheimer's legacy is complex. His brilliance reshaped physics, but his work forced humanity into a nuclear age, an age where science could both save and annihilate civilization. More than a scientist, he became a symbol of the moral weight of discovery, proof that knowledge can change the world, but not always for the better. Alexander Fleming, born in Scotland in 1881, worked as a modest bacteriologist in a London hospital. In 1928, he returned from vacation to discover that a mold, Penicillium notatum, had contaminated his petri dishes. Around the mold's edges, deadly bacteria were mysteriously destroyed. Fleming realized he had stumbled upon something extraordinary: penicillin, the world's first true antibiotic. Though it took over a decade and a global war before mass production, by World War II penicillin was saving thousands of soldiers who once would have died from simple infections. The impact is staggering. By the mid-20th century, death from bacterial diseases like pneumonia and sepsis plummeted. Life expectancy soared. The discovery of penicillin sparked the entire antibiotic revolution, leading to dozens of life-saving drugs. For this, Fleming shared the 1945 Nobel Prize in Medicine. His accident became one of the most important medical breakthroughs in history. From a messy lab dish to a world transformed, Alexander Fleming didn't just make a discovery. He granted humanity decades of life that nature once stole. Thomas Edison, born in Ohio in 1847, was partially deaf and had little formal schooling. Yet he grew into one of history's most prolific inventors, holding over 1,000 patents. He wasn't a lone genius. He built invention factories where teams helped turn ideas into usable reality. His greatest triumph was the practical incandescent light bulb. In 1879, he created a durable design and paired it with an electrical power grid, effectively bringing light to the modern world. But Edison's reach went far beyond light. He invented the phonograph, the first device to record and play sound, helped pioneer motion picture cameras, and pushed innovations in telegraphs, microphones, and power generation. His rivalry with Nikola Tesla in the War of Currents became legendary. But while Tesla provided visionary breakthroughs, Edison excelled at mass adoption. By commercializing inventions, Edison reshaped daily life. The electric age, recorded music, cinema, all grew from his laboratories. From poor beginnings to electrifying the globe, Edison embodied applied science. He didn't just invent gadgets. He changed how humanity lived, worked, and dreamed. Johannes Kepler, born in 1571 in Germany, was a frail child but grew into one of the greatest astronomers of all time. Working with Tycho Brahe's meticulous star charts, Kepler discovered something revolutionary. Planets don't move in perfect circles, but ellipses. Kepler's 3 laws of planetary motion, published between 1609 and 1619, provided the first accurate mathematical model of the solar system. They showed that planets sweep equal areas in equal times and that their speeds depend on distance from the sun. For the first time, the cosmos followed exact, testable rules. These laws laid the foundation for Newton's theory of gravity later in the 17th century. Without Kepler's math, Newton's success would have been impossible. And centuries later, his laws still guide spacecraft across billions of kilometers. NASA engineers literally use Kepler's formulas to reach other planets. Kepler combined faith, mathematics, and relentless analysis into a single vision. A universe running on laws, not guesswork. From fragile beginnings to immortal laws of motion, he decoded the celestial clockwork. Aristotle, born in 384 BCE in northern Greece, was taught by Plato but became a thinker who surpassed his teacher. For nearly 2 millennia, his writings defined science, philosophy, politics, and logic. Aristotle studied everything: biology, ethics, astronomy, physics, literature. He classified over 500 animal species, founded formal logic as a discipline, and divided knowledge into clear categories. His belief that careful observation and reason could explain the world became the intellectual backbone of Western civilization. While many of his specific scientific ideas, like a geocentric universe or spontaneous generation, were later proven wrong, his influence is unmatched. Medieval Europe called him simply the philosopher, and his works dominated universities for centuries. His method, the idea of systematically studying nature, cleared the path for modern science itself. Newton, Galileo, Darwin, all built upon a framework Aristotle first sketched. From dissecting sea creatures to debating ethics in Athens, Aristotle's curiosity was limitless. He may not have had today's tools, but he gave humanity the intellectual structure that made science possible at all.